Okay, so we have spent the last couple of days talking about chemical reactions, and we've been practicing writing them, writing the skeleton equation, and then balancing them. The next thing we're going to talk about is the type of reaction that's taking place. So, first of all, there are 5 main types of reactions, and you may have seen these before. From these, we should be able to determine the reactants and some of the products. So, for instance, yesterday or the day before, I gave you a word problem essentially, and you had to take the words and you had to make them into the reactants and you had to make them into the products, and then you had to balance them. Well, after today, I should just have to give you the reactants, and you should be able to then figure out the products and then balance it. So it's almost like I'm adding one additional step. So the first type of the 5 types are a combination, which is sometimes referred to as synthesis. The second type is something called decomposition. The third is single replacement, which is also called sometimes single displacement. The fourth kind is called double replacement or double displacement. And then the fifth type is called combustion. So let's talk about each one of these now. The first kind is the combination reactions. This one does exactly what the name says. It says to combine or to put together. We can also call these synthesis reactions. So basically, you're going to take 2 substances and you're going to combine them to make one compound. Products can be predicted, especially if the reactants are only 2 elements. So for example, if I take calcium and I take oxygen, I can then create calcium oxide. But remember, after our practice, just because we started with 2 oxygens over here, remember diatomic molecule, does not mean that there are going to be 2 oxygens on this side. Remember, when you are making your compounds, you need to make this electrically neutral. Calcium has a charge of 2 positive, oxygen has a charge of 2 negative. They are already electrically neutral, so we don't need any subscripts. So, no, this equation was not balanced, but they added the coefficients out there in front to then balance the equation. Okay, the second type was something called a decomposition reaction, and again, this does exactly what the name says. To decompose, when something is decomposing, it is breaking down. So in a decomposition reaction, you are breaking them apart. One reactant breaks apart into 2 or more elements or compounds. Energy is usually required in order to get decomposition started. So for instance, a lot of times you'll have to add heat, or you'll have to be under sunlight, or you'll have to add electricity. So an example of this problem would be calcium carbonate can break down into form calcium oxide and carbon dioxide. All right, decomposition reactions a little bit more. Products can be predicted if it is a binary compound. Now, if you remember, a binary compound is a compound made out of 2 elements. So if this right here, this reaction H2O, which is water, we just break it down right smack dab in the middle, and it is going to form hydrogen and oxygen. But remember, hydrogen is a diatomic molecule, so it's going to be H2 plus, actually I have a typo, O2, and then we would have to balance it by going 2 there, and then we would also need a 2 there. So remember, just because the subscripts are not in the initial reaction, they need to be in the final reaction. However, if the compound has more than 2 elements, like we see here, we see nickel carbonate, you must be given one of the products in order to determine the missing pieces. So for instance, if I give you a reaction that isn't obvious, where we're not just going to break it right down the middle, I will give you a little bit of information. So I'm telling you that nickel carbonate is going to break down to form CO2 and something else. All you have to do is figure out what's left. So if we take 2 oxygens away from carbonate, we'll just take that subscript away. If we take the carbon away, so all we're left with is a nickel and 1 oxygen. So that means that our product is going to be NiO. Now we need to make sure that our charge is balanced, because this is an ionic compound, right? Well, if we look back out here, carbonate has a -2 charge. Nickel is a transitional metal, so we can't look at the periodic table. But since it only takes 1 nickel to bond to carbonate, which has a -2 charge, it makes nickel then have a +2 charge. Well, the nickel's not going to change. So if nickel's +2 on the left, it's going to be +2 on the right. And since oxygen is also 2 negative, this is already neutral, so we don't need any subscripts. All right, so let's talk about the third type of reaction. This is single replacement, and I actually a lot of times call it single displacement. This is when one element replaces another. Metals replace other metals, nonmetals replace other nonmetals. I remember it as like replaces like. So in order for this to happen, a reactant must be an element and a compound. So when you're trying to identify a single replacement reaction, you have to have an element. So like for instance, if like the examples you see down here, do you see how sodium is all by itself? Fluorine is all by itself. In order for it to be single replacement, you have to have these elements all by themselves. The only way they can replace something or be a single replacement is if they are single to start off with. The products will be a different element and a different compound. So for instance, sodium is going to kick potassium out of its place, and potassium is now going to be all by itself, which we see over here. Now potassium, which is still an element, is all by itself, and it's no longer potassium chloride, it is now sodium chloride. The same thing takes place on the bottom. Fluorine is going to kick chlorine out of its place, because remember, nonmetals displace nonmetals, and then chlorine is going to be all by itself. So you still see chlorine all over here all by his lonesome, and then lithium and fluorine is now making a compound. Again, these are ionic compounds. You need to make sure they're electrically neutral, and do not forget about your diatomic molecules, which again are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. These guys will never be by themselves. They will always be in a pair if they are not in a compound. All right, the fourth type of chemical reaction is called a double replacement reaction, or again a double displacement reaction. And this is when two items replace each other. In order for this type of reaction to take place, your reactants have to be two ionic compounds. You have to have two ionic compounds. If you do not have two ionic compounds, then this is not going to be a double replacement reaction. So basically what's going to take place is it's honestly the same thing as single displacement, except this time instead of having an element, you have two compounds. So what's going to happen this time is we are going to switch places. Sodium is going to switch places with iron. Iron is going to come over here and switch places with sodium. Again, like replaces like. Sodium is not going to replace chlorine, and hydroxide is not going to replace iron. The metals replace the metals, or the nonmetals replace the nonmetals. So, since sodium is switching places with iron, and iron is switching places with sodium, if we look over here, iron is now with hydroxide, and sodium is now with chlorine. But if you notice, the subscripts are completely different, because again, the whole point of the subscripts is to make it electrically neutral. So, over here, iron has a 3+ charge, and I know this because it's bonded to 3 chlorines. Hydroxide always has a 1- charge. Therefore, to make this neutral, we need a subscript of 3. Sodium has a charge of 1+. Chlorine has a charge of 1-, so those guys are already electrically neutral, so we don't need any subscripts. Now, is this a balanced chemical equation? No, but it is a skeleton equation, and skeleton equations do not have to be balanced. We could balance it really quick, so let's just go ahead and do that. There are 3 chlorines on the left. There are 3 chlorines, or 1 chlorine on the right, so we need to fix that by adding a coefficient there. There are now 3 sodiums on the right, but there's only 1 on the left, so we need to add a coefficient of 3 right there. There are now 3 hydroxides on the left, and there are 3 hydroxides on the right. There's 1 iron on the right and 1 iron on the left, so now we have a balanced chemical reaction. All right, so let's talk about that last guy. Let's talk about the 5th chemical reaction type. Or maybe not. We're going to talk about how to recognize each type. So first of all, you need to look at the reactants. If you see an element plus an element, it tells you that it's automatically a combination. If you see just one single compound all by itself, it is telling you that it's going to be decomposition. If you see an element plus a compound, it's signaling you that it's single replacement. And if you see a compound plus a compound, it's telling you it's double replacement. So this will honestly help you to learn how to recognize the type of reaction without having to do a lot of the work. So now let's look at that 5th reaction type, and that is going to be combustion reaction. Combustion means that you need oxygen. Usually, a compound is made of only carbon, hydrogen, and oxygen, and it has to be reacting with oxygen, or in other words, we have to be burning it in some way. If a combustion reaction is complete, the products will be carbon dioxide and water. However, not all things burn completely, so sometimes we'll have reactions that we term incomplete reactions, and these will have a product of carbon monoxide, CO, or carbon instead of carbon dioxide. So if we were doing these types of reactions, we would see CO plus H2O, not CO2. So again, we have to look at these reactions, you have to look at both the reactants and the products to identify it as a combustion reaction. So let's look at an example. So let's see if we can practice classifying these. So if I look at number 1, I see oxygen, carbon dioxide, and water. These 3 things all are telling me that this is a combustion reaction. And not only is it a combustion reaction, it is a complete combustion reaction because we see that it's CO2 and not CO or just C. So when you see oxygen, carbon dioxide, and H2O, it is a complete combustion reaction. Then number 2, if we look at number 2, we see one thing on the left side. This is a compound and it's all by itself. It's not being reacted with anybody. So if it's not reacting with anything, the only thing it has left to do is break down. So that means that it is going to be a decomposition reaction. Okay. Number 3, we see an element plus an element. Well, if you're adding 2 elements together, just like in the decomposition, the only thing it could do is break apart. The only thing we can do is combine. So they will combine to form a new compound. So this is going to be called a combination. Number 4, again, we're looking at our signal reactants. We see an element and a compound. Well, when we have an element, usually that means that it's going to be replacing something in the compound. Since like replaces like, the zinc is going to try to replace the silver, and the silver is now going to be all by itself, which is exactly what happens if we look over here in the product side. So this is going to be our single displacement. And lastly, if we look at number 5, we see a compound and a compound on the reactant side. That is telling us that it has to do something. It's not going to combine. Most likely both of them are not going to break down at the same time. So if they're not going to combine, they're not going to break down, they have to be switching places. So potassium is probably going to try to switch places with barium. Barium is going to switch places with potassium, which if you look over here, that's exactly what happened. Barium is now attached with carbonate. Potassium is now attached with chlorine, which is a signal that this is going to be a double displacement reaction. All right, so hopefully that helps a little bit, and if not, you can always rewind and hear my explanations again since this is a video. But what I would like for you to do now is I want you to pull back out your writing chemical equation sheet that we've been working on for the last couple of days, and this line that you see right here, we have been leaving blank. I told you we would get to it in a few days, so now we're getting to it in a few days. And I want you to go ahead and I want you to try and practice doing this. So really quick, I did number 1 with you in class. So let's go ahead and let's try to identify that reaction type. We're just going to look at the reactant. So we have copper nitrate plus potassium sulfide. So now let's see if we can figure out what type of reaction this is without even looking at the products. Well, we see a compound and a compound. These things are most likely not going to add together. They're also most likely not going to break apart at the same time. So what's going to happen is copper is going to try to replace potassium. Potassium is going to try to replace copper. So this would be termed a double displacement. So what I would like for you to go do is I want you to go back through each of yours and I want you to identify it all by yourself. Don't ask your neighbor for help. I want you to practice identifying them. Once you are done with all of them, then I want you to compare your answers with your neighbor. But I really think that it would be beneficial for you to try to do this without asking your neighbor for help, just to see if you truly understand.